Welcome to 8.2 Angle-Angle Similarity Theorem. If two angles of one triangle are congruent to two angles of another triangle, so A and B are congruent to D and E, then F and C must be congruent to each other. So if you can show corresponding positions of angles, two of them, in each triangle, then you know the third one is also congruent. And therefore, if all the angles are congruent, then the two triangles are similar. Determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasoning. Okay, so number one, we have 48 degrees and a 90 degree. We have 90 degree and a 42 degree. Well, two of them are 90. What is angle F and angle L? So you take 180 minus 90, which is 90, and then subtract the 48, and that gives you 42 degrees, which happens to be what angle K is. So angle F and angle K are the same, and therefore angle L and angle G are 48. Okay, so it says first of all, yes, they are similar. Write a similarity statement. So triangle, the order is important here. If we said FGH, that's similar to triangle. What goes with F? Angle K. So K, and then G was the 48, so L is the 48 degree angle in the other one, and then the 90 degree H. I'm sorry, that'd be J in the second triangle. All right, number two, same thing. 180 minus 90 is 90, and then you subtract one of them. We'll subtract the 40 here. That leaves 50. So the other angle must be 50 degrees, which does not match angle W. So no, these two are not similar triangles. Number three, so there's 180 degrees in each triangle. So we do have two that are the same. So we subtract 35, okay? And that gives us 145 degrees. And then let's go ahead and subtract 85. If we subtract 85, that gives us 60 degrees. That should be angle R, which is not angle U. So that tells us no, these two are not similar. All right, number four. Angle C and angle U are the same, so 180 minus 25 is going to give us 155. So let's subtract 82 degrees, okay? And that gives us 73 degrees, which is what angle T is, so therefore angle S must be 82. So yes, these two triangles are congruent. Now let's do the right order. Triangle CDE, all right? So we got to match what C is. C goes with U. And D, 82 degrees, goes with S, and then T would be the next one. Show that the two triangles are similar and write a similarity statement. Same type of thing. So we have angle MYN is congruent to angle XYZ, vertical angles. These two angles are the same. And we have these two angles that are the same. So angle N is congruent to angle Z, and that's a given. And then we can say that triangle MNY is similar to triangle XZY, and that is the angle-angle similarity statement. If you have two angles that are the same, then the other angles have to be. And therefore, these two triangles are similar. And that's your similarity statement. Number six. Let's see here. In the top triangle, what is angle Z? Well, first of all, let me show you what we're looking at here. That's 45. This is X, Y, and Z. That's 85. Okay? And then you have the bigger one, which is W, U, and Y at the top. Again, that's 85 at the top. So you have two angles that are the same, angle Y. W and X are not the same, so we need to figure out what Z and U are. So 180 degrees in a triangle minus 85 is going to be 95 degrees, and then subtract the 45, and that gives us 50 degrees. So angle Z is 50 degrees, and if that's 50 degrees, you have 85, 50, and 45. Here we have 85 and 50 at angle W, which means this must be 45 over here. All right, so they're flip-flopped from each other. So triangle XYZ is similar to triangle. X is 45 degrees, it goes with angle U, and 50 degrees for, Y is 85, so Y goes in the middle, and Z is 50 degrees in the small one, so that's W in the bigger one. Okay, now we have two parallel lines, and so we have two triangles here. Okay, so we have the bigger one, and then we have this smaller one here. But both of them have angle N. So we know angle N is there, okay? So that's congruent to itself. Angle N is congruent to angle N in both triangles. And then you have parallel lines. So cut by this transversal here, so corresponding angles, angle LQN is congruent to angle MPN, corresponding angles. And the same for two parallel lines cut by this transversal. But we don't need that one because we already have two angles. Angle similarity is the reason that we can say triangle LQN, the bigger one, is similar to triangle MPN because of the angle similarity theorem. So we have two angles that are congruent. That's all you needed. Number 8, two parallel lines cut by, let's see here, do we have a good transversal here? There's two parallel lines, and let's see here. These two right here are congruent. That makes this a parallel line. RS is parallel to TU. And so you have this huge diagonal there, transversal. So, and it says these two are congruent. So these two lines are parallel, and these two lines are parallel. So we have another set. These two lines are parallel cut by this transversal, so this angle there is congruent to that one. That's alternate interior angles as well. So now we have two angles. We can say angle let's use the correct triangle here. VRS is congruent to RUT, angle RUT. That's alternate interior angles. And then you have the other one, angle RVS is congruent to angle URT, and that's, again, alternate interior angles. And therefore, triangle, now we got to get this right, TRU is similar. So T goes with, T is the missing angle, so that's S. SR matches the V in the red, and then that leaves, let's see, SVR. Okay, and that's going to be angle similarity theorem. Number 9, use the diagram to complete the statements. Okay, lots of different things here. CAG, triangle CAG is this little triangle right here. CAG, that's similar. You got a 90-degree angle there. So let's figure out what these are. 90 minus 45 is going to be 45, so this is 45 degrees here. And if angle A is at 53 degrees, then angle ACG, it looks like angle 4, but that 4 is the length of GC. Okay, so ACG is going to be 37 degrees. Okay, 37, which is right there. Now, if AG is 3 and the whole thing is 7, that means GB is 4. Okay, so GB and GC are congruent, which that's a 45 degree triangle, so of course they're congruent. Now let's answer a few other things here. CAG is similar to something else. So, okay, so this angle down here, angle D here which we don't have, is 45 degrees. I know that, and this is 45 degrees because of vertical angles. That's 45, and if that's 45, then angle D is 45, which this is going to make CGB similar to this bigger angle here. And therefore, this one over here, use a pointer here, CEF, this triangle is similar to this one. So that's our first question here. CAG is similar to CFE. So triangle CFE. Number 10, DCF, we just got done talking about. DCF is the bigger triangle here. It is similar to that triangle on this side. So that would be, say, DCF would be BCG, triangle BCG. And then we got another triangle, ACB, which is this big triangle up here. Let me do it in yellow. ACB, ACB, this triangle. Big triangle has to be similar to this big triangle down here because the other two are similar. So it's ACB, A it goes with E, and C goes with C, and then B is with D. I'm just matching up the letters in corresponding positions. And then, therefore, if you have two 45 degrees at B and D, but the converse theorem of parallel lines, alternate interior angles, converse says that these lines down here are parallel, which makes this 53 degrees here, and this is 37 there. Not that it's asking for that, but let's just answer a few questions here. ECF, ECF, we just did 37 degrees. ECD, ECD, the big one, add these two together here, that's 70, 82. Now CF, CF is this line here. So now we got to set up a proportion. The answer for CF is 12, only because I know 45 degree angles and this being 12 squared root of 2, these both have to be 12s. But the only way to really know that is if you do your math. If we say that's x and that's x, it's Pythagorean theorem. X squared plus x squared equals c squared. C is this. So that's 2x squared here. Here we get 144 times 2, or 2x squared equals 288. Divide by 2, and x squared equals 144. Square root, that's 12. So each of these are 12. All right? So now we have CF, that's 12. DE, this is 12, and this is 9, so that's 21 the whole way across there, adding segments. And then BC. Where's BC? BC is this right here. So we have 4 and 4. Let me draw this triangle so you can see it. So this is 4, this is 4. It wants to know this hypotenuse. So 4 squared plus 4 squared equals c squared. So 16 and 16 is 32 equals x squared. Take the square root, and x equals, got to break it down, don't use your calculator, that's 4 square root of 2 is x, or BC, 4 square root of 2. Lots of work and lots of craziness on here. Got to use everything you've been taught. All right, describe and correct the error. So first of all, let's do what we should be doing. How do we find x? So what we have on here is two parallel lines cut by a transversal. That angle and that angle are exactly the same corresponding angles, and we have a transversal here. So these two angles are congruent. So therefore, the two triangles, this big little triangle here, and then the big triangle as well. So if I do 6 is to x, then I better do this little side of the triangle is to the whole side. 4 is to 9. And see what we get here. That's 54. That's 4x. And divide by 4. And x equals, 4 goes into 5 once with a remainder of 1. 4 goes into 14 3 times with a remainder of 2. So, and 4 goes into 25. So 13.5. You can do long division if you want. So x should be 13.5. So what do we have to set up here and what they have to set up? They have 4 is to 6, which you could do that, but then they better have 9 is to x, and they don't. So they used this triangle and then they only used a portion of the bigger triangle, the 5. They needed to use the whole thing. That's what they did wrong. All right. In one triangle, measure of angle A is 31 degrees. All right, we don't know what this is. Let's just try. I'm going to draw generic triangles. They're not going to be correct here, okay? So A and B. So it says this is 31 and this is 97. Obviously, 97 degrees doesn't match the picture I drew, but we're just randomly putting them in there, okay? In a second triangle, angle D is x plus 6, and angle E is y minus 4. For which of the triangle values of x and y are the two triangles similar? All right, so basically what they're saying is angle A has to be equal to angle D, and angle B has to be equal to angle E. So just figure them out. X plus 6 must equal 31, and y minus 4 must equal 97. So we just figure both of these out. So we subtract 6, and x has to be 25. So right there, that's the only one that says 25. So the answer is going to be A. Let's just go ahead and do the rest of this. 4, y has to be 101. Okay, so what we see here is because this is college prep, that maybe it's the other angle that we don't know. So let's look at the first triangle here. 31 and 97 is 128, okay? And that leaves 52 degrees here. And maybe the y minus 4 is equal to, the angle E is equal to this other angle. So if we did y minus 4 equals 52, then all of a sudden you add 4, y equals 56, which again, the answer is A. Pretty hard to go through this. We don't know what this angle is. We're trying to figure out what x and y are. So what they did is E was actually up here to match whatever angle C is. Okay, so that's why it's a college prep. You can't just give up so quickly. All right, modeling real life, a saguaro cactus casts a shadow that is 30 feet long. So 30 feet long, this is straight up and down 90 degrees. 30 feet, not 30 degrees. At the same time, a person standing nearby who is 5 feet casts a shadow. Again, that's 90 degrees. He is 5 feet tall. 5 feet 10 inches tall. Cast a shadow that is 50 inches long. Now be very careful. We have two different increments here, inches and feet. How tall is the cactus? All right, so we don't know. We'll call the height of the cactus y here. Okay, so we need to change either the 30 feet to inches and the 5 feet 10 inches to total inches, or change all the inches into feet. Let's change everything to inches. So 30 times 12 will give us the inches here. All right, so that's 360 inches. That's 12 feet. And the 5 feet is 5 times 12 is 60, plus the 10 is 70 inches. Everything's in inches. Okay, so let's do a proportion. 50 is to 360 as 70 is to y. So 50 y equals 7 times 36 is 210 and 42, 252 and 2 zeros. So you can use your calculators. Divide by 50 and quick shortcut. 2,520 divided by 5. So this is how I do it. 5 goes into 25 5 times. No remainder. 5 goes into 2 0 times. Carry the 2 over to the next 0. 5 goes into 24 times. So y is 504 inches. Okay? So I'm not sure what they're going to ask for in big ideas on the program. So let's divide this by 12 to give the feet. Okay? So 504 divided by 12. That's 4. That gives you 48. 2, 4, 2. So that's 42 feet tall. Holy cow. So either 504 inches or 42 feet tall. Those are the two possible answers. Modeling real life. You can measure the width of the lake using a surveying technique as shown in the diagram. Find the width of the lake, WX. Justify your answer. So you can do this along with some trigonometry once you get to trig. Trig is much faster, but you can do it as well with this, all right? So now you have two parallel lines, notice that, cut by transversals. So the point is you're trying to show similar triangles. So first of all, vertical angles, and then alternate interior angles are equal. So you have two angles now in the two triangles, so by the angle-angle similarity theorem, the two triangles are similar, okay? So if the two triangles are similar, then you can set up all the proportions. So 8 is to 104 as 6 is to wx. So 8wx is equal to 624. Divided by 8. 8 goes into 62 7 times, so wx equals 7, which 8 times 7 is 56. 62 minus 56 is 6. 8 goes into 64 8 times. So 78 meters across that lake is the answer. 21. To determine the height of a telephone pole, there's a telephone pole. Your friend tells you to stand in the pole's shadow. So we'll just make the pole shadow this way here. Okay. So the tip of your shadow coincides with the tip of the pole's shadow. So you're standing right here. Okay. And your friend claims to be able to use the distance between the tips of the shadows and you, the distance between you and the pole, and your height to estimate the height of the telephone pole. Is this possible? Explain, include a diagram in your answer. Okay, so first of all, you have two triangles here. You have you and you have the telephone pole. Well, first of all, those two angles are the same, and so is the 90-degree angle. So you have two angles. So by the angle-angle similarity theorem, the two triangles have to be similar. Okay, so if they're similar, then these two triangles, you can use proportions to figure out the height. All right, because you can measure the length of the shadow of the telephone pole, and you can measure the length of your shadow, and you know how high you are. So it's just like the last problem. Here's all the answers up to 21. How do you see it? In the diagram, which triangles can you use to find the distance x between the shoreline and the buoy L? Explain your reasoning. Okay, so if you have similar triangles, so we have two triangles here, the triangle in the water and the triangle from the buoy into the sand. So let me draw these separately. So this is in the water. We have X, K, and M, and L is up here. And this is 100 meters. And then we have the bigger one, L, J, and N. And 25 and 100 make 125. And this is 20 plus x, or x plus 20 here. All right, so we know the two triangles are similar. There's one angle, and then parallel lines here cut by transversal. These two angles are the same. So there's your two angles. And also you could just use angle L in both the triangles are congruent. Okay, so you just set up your proportions and solve it. So x is 2, x plus 20, as 100 is to 125. All right, so we'll get we do 125x equals 100 times this whole thing, 100 times x plus 20. Now you have to distribute the 100, don't forget. So 125x equals 100x plus 20 times 100 is 2,000. 2 times 1 is 2, and you have 3 zeros there. Shortcut. So subtract the 100x, that gives you 25x equals 2,000. So 2,000 divided by 25, that's going to give you 80. So x is 80. 80 meters. It's a long way to swim. Okay, is it possible for JK and L, triangle JKL, to be similar? Explain your reasoning. So each of these is different. So we're going to draw generic triangles for each of them, J, K, and L. And then you have X, Y, Z. X, Y, Z. Okay, angle J in number 23 is 71 degrees. Angle K is 52. Angle X is 71. Okay, so there's those two that are congruent. Angle Z is 57. So how do we figure this out? Well, you got to find the missing angles. So 180 minus 71 is 109. Subtract 52, and that gives you 57, which matches angle Z. So angle L and angle Z are the same. So there's your similarity. You have two angles. Angle, angle, similarity is how. All right, so let's erase all of that. And we'll go to the next one. Draw two generic triangles and start all over. Okay, so JKL is a right triangle. So there's 90 degrees. X, Y, Z, X plus Y equals 150 degrees. Okay, so we don't know what Z is. So JKL, XYZ. Now these are in a specific order. Okay, so I know that X and Y have to equal 150, and angle J is 90. So if these two are equal to X and Y, then that means angle K has to be 60. And if X and Y added together equal 150, that means there's 30 degrees left for angle Z. And of course, there's 30 degrees left for angle L if you subtract 180. So this is how this has to be done. So yes, they are similar. All right, so let's erase all those. And it's okay. And I'll draw it again on number 25. So JKL, angle L is 87 degrees, and XYZ, angle Y is 94 degrees. So do we have enough information? No, we don't have. You need at least another angle, and we don't know if it's a right, it's obtuse, or both acute. We don't have enough information. So no, we can't. We don't have enough information to say they're similar. Okay, they may be similar, but we don't have enough information to show it. So let's erase all of that. We'll do it again. Last one here, number 26. So JKL, J and K add up to 85 degrees. That leaves, at 180 degrees in a triangle, that leaves 95 degrees for angle L. All right, and then we have X, Y, Z. Y and Z add up to 80 degrees. That means angle X is 100 degrees. So no, these can't be similar at this point. So you'd say no for that. Not possible. And there are your answers. They do it a little bit differently, but that's how you do it. And that's it. Good job.